Hello! Today we're here in Burbank and Woodbury University, and with me is my friend and colleague Kishani De Silva, who is a professor at the university who designed and built and made happen this beautiful 3D printed house. Hi, Kishani.
Hi, Julia.
How did this idea of this 3D printed house came to be?
So I work with the student team and lots of outside stakeholders. So it was not just me, but a whole team of people. We entered a competition with the Department of Energy called the Solar Decathlon. And the student team and I worked the first semester, and we won that first phase and were given some seed funding. And the project just became very real at that point. So 15 months later, we were able to raise some funds and get it to what we call substantial completion. That was last summer. And now it's complete. We're just waiting for the certificate of occupancy.
Wow, so it's going to be permitted by Los Angeles Department of Building and Safety?
Correct.
Was it hard to get approved?
They were very supportive of us. I think they also wanted to see something like this happen for LA. So it's the first permitted 3D printed dwelling in Los Angeles. Yes, some things do take time, and some things you don't really understand why. But overall, I would say that the permitting was pretty fast. So we submit the drawings end of that year, June, and we got the permit end of September to start building. So that was pretty fast, I would say. And then coming on that substantial completion deadline, which was when the students had to present in Colorado for the Department of Energy, that was 15 months. So we were at 80% completion at that point.
Oh, wow. What was the biggest challenges in getting the approval from LADBS? What was the biggest comments or concerns?
The concern was whether 3D printing would be allowed. Iteration of this technology here in Los Angeles. We had to work with some of the traditional means and methods, if you will, and get it permitted through the city. So the next generation might be a little bit more difficult in terms of making the 3D printed concrete structural. So that was kind of the big question mark for us. Will it be possible to do it?
Right.
And I think that was a question the city had as well.
So this is structural concrete, right? That's printed with a robot hand. Right?
Yes, it is structural concrete, but it's not approved as structural concrete. So the center cavity is where all the structure happens.
Okay. And how thick is the center cavity?
6 inches.
6 inches, and the
2 and 2.
2 inch.
Yeah.
So is it functioning essentially as a form?
Yeah, it is functioning like stay in place formwork. But one of the most sustainable features of that is the fact that there's no waste in building formwork. There's cost reduction because of labor, and so it speaks to sustainability in terms of waste reduction. The formwork is not going to the dump, pretty much.
Right.
Yeah.
And it's also beautiful finish.
Correct. So it acts as a finish, a cladding. And it's also the structural concrete. We made it quite sustainable. We reduced cement content by 40%. We had carbon capture in it, so our carbon footprint for the concrete was reduced quite a bit from a traditional concrete that's usually used.
And obviously there is no butt insulation. It's like just a concrete wall. So do they perform as a thermal mass?
Correct.
How well is that?
So it is thermal mass because it'll hold the temperature, and I think you noticed when we went inside it was a little cooler. So that's one of the benefits of the concrete. We have insulation on the pony wall and on the roof. Quite a bit of insulation, and our R values are pretty high up there. Yeah.
Okay.
For that.
Great. Can we go inside?
Yeah,
see what's in there?
Go ahead.
the MEP system built into the house? Was it all embedded in the walls, or all the pipes for electrical and...
Right. So on the mechanical side, the water comes through the mechanical room from the exterior. But for the electrical system, yes, we did embed it. So that's one of the other advantages of 3D printing, that you can coordinate the trades early on, and so there's less errors happening. Before we poured the concrete into the cavity, we dropped the conduit. When the concrete was wet, the students were all placing the sockets in the wet concrete, cutting it out and placing it. So when the electricians came to do it, it was pretty seamless because it's already in place. They just ran it from one place to another. The plumbing for a bigger unit would probably have the same sort of coordination. For us, it was just a little bathroom and the kitchen. So this is like the plumbing wall for that. And so we ran it through the mechanical room. There's a Greywater system. This is also the first use case for the Greywater in a sort of a single family application, and we had to get that permitted through the county as well. But that was a separate standalone unit, so it didn't have that level of coordination that was needed. We just need to make sure that it was stopped in.
So the grey water that flushes the toilet is permitted? Is it rainwater that's collected? Or?
It's coming from the shower. So every time somebody takes a shower, it goes into
collection tank,
sump pump, and then it recycles and comes through the system in the mechanical room, and then it goes for toilet flushing.
And it was approved by city and county in Los Angeles. So that's great.
Yeah. So you can now use that system if you want in your home.
Oh, anyone can?
Yes, anyone can. So it was used in multi-unit situations, like maybe apartment buildings and stuff like that, but not just for a single family.
Okay, but it's not a specific brand. It's like anybody can install a tank, a sump pump, filter, and
correct.
Yeah.
But we used a company called Greywater. They were really good. Yes, Greywater, Greywater system.
House is connected to city water supply, and these two pipes are portable water system. But to minimize the use of it, there are also 3 different collection systems for recyclable water. Behind me is the large green tank that collects water on the roof. And there are 2 high roofs on this house, and they slope in different direction. And at the end of this slope, there is a gutter that collects the water to one point. And so this is a first roof collection of water that can be reused for landscaping or for other purposes. In addition, the other roof slopes opposite direction, and there are water collected, and that water is the special planter that would collect all the water and filter it through. But that's not it. There is another 3rd system of water collection that collects water from the shower, and this water goes underground, and there is an underground pump, and over there you see the power for this pump, and that water through this pipe goes back to the house, and it's filtered through the special filter system, and after that it is used to flush the toilets. And this is the first system that was approved by City of Los Angeles, where you would use shower water to flush the toilets, and it's very successfully installed here. And this is a net zero and net positive?
Correct. It's net zero. It might be net positive, but we can't really say because no one's using it right now.
Right. You need to test.
It was designed to be net zero, and it's also can stay off grid if something happens. We had to permit it in a way that it was connected to the university because it was not allowed that we could stay off grid. But now I think that's sort of changing a little bit. So if anything happened to the grid, you could potentially have your power, and this is the storage for that. This is something that probably won't be living in here, but for now it's here. So this gets plugged into the inverter, and the electricity gets stored in case you need it. You can move it out, it's mobile, and charge your car if you want.
Okay, and then so the solar panels on the roof.
Correct.
And you have like a room for solar for electrical room, or?
So that's the electrical room.
Okay, there is a room
Right.
for that. Okay,
Right.
Great.
So that's where the inverter is, and power comes in there, and then gets distributed to all of the sockets and things like that.
Portable power system that can be connected to solar panels and generate power for the entire house with 8 outlets, regular 120 and additional 240 various outlets that you can directly attach your air conditioner system or any other systems in the house that require extra power, and also electric car can be charged through the same system. And it's so portable, it can be rolled outdoor, and all the connections are waterproof for outdoor use, and also there is a connection to do grounding, so it will be safe to be used outdoor as well as indoor. And it's designed for one person.
It's designed for one person, but as you can see, it's quite spacious, and 2 people can easily live here, I think. The bed pulls out, it becomes a like a double bed. I think you wouldn't bump into each other if 2 people were living here.
Right.
It's way bigger than a dorm room. So.
Right. Yeah, you also have very high ceilings. It's very aesthetically very pleasing with exposed joists, but there's no insulation here.
There is. So yeah, that was a design strategy because this is only 425 square feet of living area. So everybody thinks it's just very small, but when you come in, you don't feel that because of the design strategy of making it sort of a double height space. There is 9 inches of insulation.
9 inches? Oh, that.
And yes, we had to do that because obviously we had to meet Title 24.
Right.
And it's a mineral wool, so it's a rock wool, and it's also a first line of defense for fires. We have a metal roof, and then we've got 9 inches of fire retardant. That's a Greywater system kicking in. Fire retardant material, so that hopefully it will be fire resistant. Of course, concrete as well works well with fires.
Right. And I see fire sprinklers. Were they required by code as well?
Yes,
because it's a freestanding building, right?
Correct. Correct. So the code requires that. I believe the rule of thumb is if somebody's going to sleep overnight, then you need to have fire sprinklers. I think it's relatively new, and maybe it's because of the world we live in right now with all the fires going on around us as we speak.
Right. And it's going to be living quarter for students, or it's going to be like a museum or a little?
No, I mean, we do need to, the intent was that we house somebody, and this is why we've been working towards a certificate of occupancy, so somebody can live here. And we would like to see somebody live here, preferably a student, so we can measure some of the outputs, right? Like, is it performing like we expected it to perform? How much of energy does one person consume? How much are we giving back to the university? How are we capturing the rainwater? These sorts of things need to be measured. How well is the concrete performing as a thermal mass? So lots of things to measure. I mean, we have really good windows which have a very low U value, and that also helps with the microclimate. As you can tell, it's cooler inside than outside.
Well, that's great. Well, thank you very much. Thank you for your time.
Thank you.
It was great to be here. This video was brought to you by YouTube channel WELLROOM from Woodbury University in Burbank. Thank you very much for watching. If you like this video, please like and subscribe to my YouTube channel. Thank you very much.